What else can we mess with? I'd actually just also introduce the attribute wrangler now. Both of these nodes make or traffic in Vex code. Vex, again, is the C-style language that Houdini uses. It's very fast. It's like C is. It's run very close to the hardware. It's multi-proc. If you do it with VOPs like this, it's still just going to make code. You can look at it here if you're interested. There it all is. It looks a lot like C if you're used to that. Probably makes more code than we need. It's a little too verbose. And sometimes people like to make wrangle nodes to address that. Or we can write exactly the code we need. So in this case, what do we have here? Well, one of the things that we have is this age attribute. I'm going to turn off everything but that for a moment here. So the age is in seconds, and it goes up to 0.5 before everything dies. And if you remember why that is, that's because on here, the lifespan is 0.5. So it kills all those points off once they get to 0.5. So I would say, why don't we set the density to be fully on in the beginning and then fade off until it dies. So F means float, at means it's an attribute. So putting this before it, F before it basically means we're making a new one. So density is going to be a new float attribute. And it's going to be equal to the age attribute we already have. And because it's a C-style language, we put a semicolon. And that's it. So now we have this density attribute, and you can see that they are exactly the same. Cool. Now these are great to use, these wrangles and stuff. Again, I mentioned they're multi-proc, and that's particularly important when you've maybe got thousands, millions, billions of particles. You're going to want to take advantage of that multi-core functionality. So the density is equal to the age, but the age starts at 0, which means the density starts at 0. We wanted the density to be fully on at the beginning. And also, we don't want it to get to 0.5 and only ever get to 0.5. So let's normalize the density first of all, meaning let's have it go from 0 to 1 instead of 0 to whatever the age is, because we might change the age later. So lifespan is a parameter literally called lifespan, as you can see here. Oh, okay. That's what I get for using a graphics tablet. You can see it there, lifespan, on this debris source 1. So let's actually read that. And you read that kind of the same way you do an H script also, which is CH for channel. And we're going to look down a level and over to debris source 1. Debris source 1. And lifespan was the name of that attribute. And I don't know where that 0 is coming from. Kind of weirding me out. But anyway, great. So now when I look, it's going to 1, because it's dividing 0.5 by 0.5, and 0 by 0.5 is still 0. So we've effectively normalized it. Cool. And so getting back to the thing I was starting to say, we want density to start at 1 and go to 0 over time. So how are we going to do that? Well, that's easy. That's probably the easiest thing we'll do this entire lesson. That's just going to be 1.0 minus that. Order of operations says that we don't need to put all these parentheses, but sometimes having a million parentheses makes things easier to understand. Cool. So basically it's going to do that normalization first, and then it's going to say, well, 1 minus that. So it's going to get the opposite, or the complement of it, really. So there you go. Now density starts at 1 and goes to 0 over time. Or nearly 0 anyway. Cool. So that'll be all ready for our volume or fluid source later. And while we're here, let's also make a p-scale attribute. P-scale is going to be the radius of the point, which the fluid source will also look at. For now, let's just make it be the density. And we don't need to do the F at this time because there's only the one density. It's this one. So that's fine. And you'll see here that it's just the same value now as density. And for the sake of argument, I would just like to show you that you can set colors and things, which can be useful. It's a vector, so we do v at, and to set a vector, we use the set. So we're just going to say density 3 times, and that'll populate it like that. Or maybe we'll go something cooler. We'll make this be 0, and this will be 1.0 minus density. And won't that be cool? Look at that. Wild. So now it's going to start red, and it's going to move towards blue over time. Cool. That's just a fun way to visualize. We won't actually do anything with that color, probably. All right. So I'll just say this is initializing other variables. I'm not going to cache this because you can see how fast it is. And it's not dependent on a sim anymore because it's dependent on this instead. So we'll just keep it as is. That way we can change things on the fly if we need to and not have to wait forever. Great. So let's just give that a little out thing. We'll say this is the actual source. And great.